Tonight, I just want to do a little bit of direct instruction. We've done lots of exploring with triangles and deciding whether or not, when we're given side lengths or we're given angles, whether or not we can form triangles. Tonight's objective is I can explain with given measures, whether I give you side length measures or I give you angle measures, why those measures either form a unique triangle, more than one triangle, or no triangle. I'm going to look at some cases tonight. The question is, will a triangle form? Decide if the following cases create no triangle, a unique triangle, or many triangles, and then we'll have to explain our decisions. Okay, so I'm going to look at case 1 to start. In case 1, we're given 3 side lengths. We're given a triangle with a side length of 3 feet. I can call that side 1. We're given a triangle with a side length of 4 feet. I can call that side 2. And we're given a triangle with a side length of 5 feet, side 3. We know when we're given 3 lengths, we just have to decide if we're given a side length of 5 and I have to create a side length of 3 and 4, will I be able to make a triangle? And you try to visualize in your head. Maybe that's maybe something like that. That would be like a 3, that would be a 4, that would be 5. It would work because if I laid this 3 down, if I laid that 3 down and then I laid that 4 down, we definitely would be able to overlap to create something longer than 5, and that's what we need to be able to close off a triangle. When given 3 side lengths that satisfy the triangle inequality theorem, you'll be able to form a unique triangle. So the triangle inequality theorem, you really have to check all 3 pairs of sides, but we know if we take the shortest sides, the 2 shortest sides, and add them together and we get a length greater than the 3rd side, we're guaranteed that we can create a unique triangle. So if I look here and I do side 1 plus side 2, and that's greater than side 3, I know I can create a triangle. Now really, that only works because these are the 2 shortest sides. You should also, for yourself, check side 2 plus side 3 and make sure that that's greater than side 1. And you should also check, what's our 3rd pairing, side 1 and side 3? You should also check side 1 plus side 3 and check that that's greater than side 2. If that works, then you're guaranteed to have a unique triangle. You can actually form a triangle. So if I do here, side 1 is 3 plus side 2 is 4. I'm hoping that's greater than side 3, which is 5. Well, what's 3 plus 4? 7. 7's greater than 5. Boom, that works. As soon as I know the 2 shorter sides added are greater than the longest side, I know I have a triangle, but I'll go through all 3 inequalities just to show you. If I take side 2, which is 4 feet, plus side 3, which is 5 feet, that has to be greater than side 1, which is 3 feet. 4 plus 5 is 9. Is 9 greater than 3? It sure is. That works. And then we'll go back side 1 plus side 3. So then you have 3 feet plus 5 feet. That added together, that sum has to be greater than 4 feet. 3 and 5 is 8. 8 is greater than 4. Boom, it works. So I now know in case 1, I formed a unique triangle. And if you had to give your reasoning, you'd say because those 3 side lengths satisfy the triangle inequality theorem. Whenever I add 2 pairs of sides, I get a length greater than the 3rd side. So case 1 forms a unique triangle. Let's take a look at case 2. In case 2, I'm given 3 angles. I'm given a 30-degree angle, a 60-degree angle, and a 90-degree angle. So right now I'm going to look at case 2. When you're given 3 angles that add up to 180, you'll be able to form many triangles. So if I look here, these are 3 different triangles with a 30, 60, 90, 30, 60, 90, 30, 60, 90. And all I've done is change the lengths of the sides. It doesn't change the angles. We're just blowing it up and making this original triangle a little bit bigger. And so the side lengths all get a little bit longer, but the angles at which those sides meet don't change at all. So as long as you blow up all the side lengths proportionally, the angles at which those 2 sides meet won't change. You can make many triangles if you have 3 angles that add up to 180. So you just check 30, 60, 90. As long as those add up to 180, you can blow up those sides as big as you want, and the angles at which the sides meet won't change. So 3 and 6 is 9, 9 and 9 is 18. Absolutely. So case 2 has many triangles, and what you say, it's because the 3 angles add up to 180. I can blow up those sides proportionally, and the sides will still meet at the same angles. So we can change the side length, but if you're given a 30, 60, 90, you'll have many triangles that can be created. All right, let's look at case 3. In case 3, if you have 3 side lengths that do not satisfy the triangle inequality theorem, you will not be able to form a triangle. So let's just double check. Again, if I take my 2 smaller sides, I could call this now side 1 and side 2, and this side 3. These are my 2 shorter sides. If I take side 1 plus side 2, I check that it's greater than side 3. If it's not, there's no way I'm forming a triangle. If I have 6 plus 10, is that greater than 20? Well, 6 plus 10 is 16. Is 16 greater than 20? No. Therefore, no triangle can be formed. And I have a little visual for here for you. If you take that longest side, 20 centimeters, and you say, okay, can I form a triangle with side lengths of 6 and 10? Well, there's one with 10 centimeters. There's one with 6 centimeters. You can see there's this huge gap here. There's no way that I can form this into a triangle. Because if I laid them out flat, there'd be no space here in between to form a triangle, and we have this huge gap. That's why it physically can't work. If 2 of the sides added together is shorter than the third side, there's no way to then lay them down and have any sort of a gap in there. You need those sides longer. So there's no way. Case 3 is no triangle. And no triangle can be formed because this does not satisfy the triangle inequality theorem. When I add 6 and 10, it's a number less than 20. All right. I want to look at one more case because this happens. Anytime students are given 3 angles, they're like, oh, I can form many triangles. Well, sometimes that's not the case. So this is like my little case 4. If you're given 3 angles that don't add up to 180, you can't form a triangle. So let's say I give you a triangle and I say, oh, it's a 90-degree angle, a 90-degree angle, and a 30-degree angle. Well, if I add those all up, that's already 180 and 30 more. 180, 190, 210. 210 degrees is not going to form a triangle. And let me just try to visually, it's not going to be beautiful, but let me show you why. Because if and this is an ugly 90-degree angle, but if I make a 90-degree angle there, and I make a 90-degree angle there, okay, look there's no way this is ever going to form a triangle. I don't care how long I extend those sides. They're going to be equidistant, and there's no way suddenly we can make a triangle out of it. So if you don't have your 3 angles adding up to 180, no triangle can be formed. So I know that we've done a lot of exploring with it, but I felt strongly that I just had to solidify a couple of cases and make sure you've had some direct instruction on it. All right, hope that helps.